Hi guys, today I'm going to walk you through 7-3, finding the area of a trapezoid. Let's take a look at example 1.
How can you find the areas of special quadrilaterals? Think about this question during the lesson. The pasture is in the shape of a trapezoid. A trapezoid is a quadrilateral that has only one pair of opposite sides that are parallel. What is the area of the pasture?
Let's find out.
What do you know about the top and bottom sides of the trapezoid?
We know that the top and the bottom should be parallel to each other. So that will come into play when finding the area of a trapezoid.
The top and bottom sides of the trapezoid are parallel. You can use structure by decomposing the trapezoid into a rectangle and triangles. How can you decompose this trapezoid into a rectangle and two triangles? Draw.
If you're trying to divide this into a rectangle and two triangles, notice that if you would draw an imaginary line right down from this corner on down, it would make a right triangle. If you would draw a line from this corner on down, it would also make another right triangle. So you would have two right triangles with a rectangle in the middle, and it will do that for you here in a second.
Two line segments from the top vertices that are perpendicular to the base. Find the length of any missing base or height. How can you find the base of the triangle on the right?
If you
subtract the sum of 10.
If you take the base of the bottom, you know that the base of the bottom and the top here, if you would extend this, it would equal 18. Okay, so there's a difference here of 8 yards because 18 minus 10 yards is 8. Okay, so this portion here missing, along with this portion here missing, if those two line segments were exactly the same, should add up to equal 8. Well, they're both equal, so that would be 4 yards and 4 yards. So then that would give me 4 plus 10 plus 4 would give me 18 yards.
10 yards and 4 yards from 18 yards. Find the area of each shape. What is the area of each triangle? Select your answer.
If you would take the base times the height times half of each triangle, that should give you 24 yards squared, if I'm doing my math right. But keep in mind, you have two of those. So you're going to have to add 24 plus 24 and then find out the area of the rectangle and add that to it.
The area of each triangle is 24 square yards. Find the area of each shape as shown.
Okay, they got the length of the rectangle, which is the longer side, was 12 here, which was also the height of the triangle, and the base right here, which is 10. Okay, 10 here, not 18. It does not extend all the way from this corner to this corner. It is 8 yards wide and 12 yards long. So 8 times 12 would be 120 yards squared. What do you think we're going to do with the 24 yards squared? Keep in mind there would be two of them, and the 120 yards squared.
Add the areas of the triangles and the rectangle. The area of the pasture is 168 square yards.
There is another way to decompose the trapezoid to find this area. Drag the slider to see the steps. You could draw the diagonal of the trapezoid. You see that there are two triangles now here. Okay. Sorry, I skipped one. Find the area of the upper triangle, which is this one right here. Okay. You could find the area of the lower triangle, which is this one right here. We had a base and the height, which would be the same as this triangle, times half. You would do the same thing here. We would have the base times the height times half. And keep in mind the base here was 18 yards and the height was 12. Add those two together and you get your area. That's another way to look at it.
Now you know how you can find the areas of special quadrilaterals.
Okay, let's take a look at example 2. Okay, if we take a look at this question, a builder needs to cut one stone in the shape of a trapezoid to fit in the space. What is the area of the front side of the stone? They're looking at this part right here, okay? If you were going to dissect this trapezoid, we could cut it into 3 different shapes. It did that for you down here. There's a triangle here with a base of 4, a height of 5, a triangle here with a base of 2, and a height of 5. Okay. Notice that this area right here, this length is the same as this length. It gave you the total length of 12 as the base of the trapezoid. So 2 plus 6 is 8, plus 4 more will give you the 12. You should be able to find the area of this triangle, find the area of this triangle, and this rectangle, add them up, and you can get your area. Before I give you the answer, I want you to try to do that. Go ahead and pause the video. Try to find the area of each triangle and the rectangle and add up all of your areas. Pause the video and get your answer, and then you can play it again once you get your answer. Okay, here's your answer. You have your triangle to the left, had a base of 4 and the height of 5, and then they multiplied that times 1/2 or divided it by 2, and that equaled 10. Here's your other triangle. It had a base of 2 and a height of 5 that we talked about. They divided that by 2 or multiplied it times 1/2 and got 5. And here's your rectangle. It had a length of 6 and a height of 5, and they got 30. They added 10, 30, and 5. They added all the areas here, and they got 45 inches squared. Hopefully that is what you got. Okay, here's an additional example. Finding the area of a kite. Let's take a look. A kite is a quadrilateral with 2 pairs of adjacent sides that are equal in length. Jackson has a rectangular piece of cloth that has an area of 298 centimeters squared. Does Jackson have enough cloth to make the kite shown? So here's your kite. You're wanting to compare 298 centimeters squared to the area of this kite. Okay, notice that they took and dissected this kite into 3 different sections, and I'm going to run out of time here. I want you to see if you can find the area of this kite and go on to the next slide on the YouTube channel to extend this lesson.